So if you are arranging objects in an order, the following pattern comes up. Okay, so here's, right, this old question, an iPod, okay, maybe it, and he's got this really extensive music library of 7 songs. And he wants to play 3 of them. So he has to make a decision, which song is he going to play first? He's going to play 3 different songs, which song is second, which song is third. He has any of the 7 songs could be first, doesn't listen to the same song again, so then only 6 choices, and then 5 choices. And if this pattern continued all the way down to 1, we could notice the following, that 7 times 6 times 5 is the same as 7 factorial over 4 factorial. And so we can make a formula for this that says if you wanted to arrange a certain number of objects in a row and repetition wasn't allowed, then you could just do n factorial over n minus r factorial. So for his 3 songs, he would have 7 factorial over 7 minus 3 factorial, which is 7 factorial over 4 factorial, which is the same as 7 times 6 times 5. Now, this formula has its place, but we will find we don't use it often because the spaces are usually easier. I have 3 decisions to make. 7 choices for the first, 6, then 5. That's easy. Okay? Where the formula might be nice is you have, I don't know, 80 different chocolate bars, and you want to eat 50 of them. How many different ways can you eat them in a row without feeling super sick? I don't know. But because the numbers are big, drawing 50 spaces might be annoying. So then the formula has a place. If you have very big numbers, the formula lets you write it quick. But for most of the questions we do, it's going to be just fine to do 7, 6, 5. And this is on your calculator, so you need to find the permutations button on your calculator. We're going to plug in 7p3. So if you have a graphing calculator that doesn't freeze, it would look similar to this. Then you could hit the math button and go over to probability. There we go. Still frozen. And under probability, you'll see NPR. Usually you have to put, so this number would be 7p3. So often you have to push the 7 button first on this calculator, go to math, go over to probability. The second one is NPR, push 2. The 7 automatically gets put in front, then you put the 3 after, and you get 210, just the same as 7 times 6 times 5. But for the most part, we will still use the spaces question. 8 students are competing in a 200-meter race. How many ways can the students finish first, second, and third? You're not worried about the rest. They don't get a ribbon. They don't get a medal. Just first, second, and third. So how many different ways could you give out first, second, and third? Well, we have first decision. Who's going to finish first? Any one of the 8 people. Who's going to finish second? Well, same person can't finish first and second. That would be a crazy race. I'm imagining it. I think I figured out a way that the same person could finish first and second. Everybody lines up. They start the race. Person who wins goes all the way around once. They decide to go around a second time and lap everybody and come in second as well. Could happen. Could come in first and second. Probably not. So then your number of choices for second are only 2, and then third, 8 times 7 times 6. This would be the same as 8p3. And one of the things with this formula that I find helpful is this number is your decisions number. That's your number of spaces. And this number is the number you start with. So if I had 3 spaces starting with an 8, 8, 7, 6. So questions for practice on this one are 4, 6, 7, and 8.